Hello friends, in this video I would like to share an app which I have developed using multiple LLM and completely local. Idea of creating this app was to uh, have an initial template which we can further enhance and further develop it as per our need in future. So this app give us a kind of a full control on LLMs which is locally installed and customize it as per our need. So what I'm going to do in this video is explain the entire application architecture first so that we understand how each components are placed and how it is controlling the LLMs and how we can tweak it in future if need to be. The second part I want to cover is the installation part. I know there are some difficulties most of us face when locally installing the things. So I would like to cover some basic things which ensure that your app is once you do those steps, your app is running and functioning. And finally, I think it's very important for all of us if we want to utilize this app in future, how do we tweak the code. So I want to do a little deep dive into the main aspect of the code where we can modify and customize it for our future need. So let's dive into it, and I hope you will like this video. Thank you so much.
Hello friends, in this video I will like to cover the entire architecture of this application so that we understand how each components are connected and how we can control LLMs and how this application is working. So if all this everything under this blue uh, lines is local machine, there is only some portion of which is going to internet for searching if needed. Now for this application, the first thing we definitely need is locally installed LLMs, for which we are using Olama local LLM server, where all these three models are stored and running. Once this is stored and running and the application has been run through Python code, we will have an application look like this one, which has two components. One is says research and max assistant, and the second one is PDF rec content. Now for this particular application, I want to show when somebody types some information in this text box. Basically you can enter any questions here, similar to how we interact with any of the LLMs, known LLMs. This is your own application where you can write anything to this and click submit. As soon as you click submit, I want to go back to this architecture view to let you know when user submit information, what happens behind the scene and how each steps are performed. So left hand side portion I'll cover after I cover the right hand side. Basically this is a PDF portion of it, and this is where the research and assistant portion of it. So as soon as somebody submit the text in that front end, what happens, this goes to a node called router node, where router node is nothing but it's an LLM which is a Lava 7B, which has its own, I'll say, kind of a brain, will read through the text and decide whether the question or the text is related to a max problem or something else. So it read that text and give an output stating it's a max or analyze text or something else. So let's say if it is not related to max, so what happens, the program will follow this path, which is analyze path, and go to this node called analyze node and trigger web search. Basically use DuckDuckGo as a tool, go to the internet find the information, send it back to this node where Lava 7b, again this model will be called to understand the information given from the web search tool and create an insights, basically a sort of an information, which that information will be passed to this another node which is called final summary node, where again a Lava 7 bin is called. The task of this node is to take the information coming from this flow and put it into uh, 2 or 3 sentences, so that it can be like a final thing people want to read and understand from all the information shared, and send it back to the user in their front end. So if I go switch to the application, so let's say this is the question somebody has asked and click submit. It has found the information from the internet. Then this is from the DuckDuckGo's part of it, and then this the middle portion where inside says it's the Lava generating information from this into more of a insight. And finally it creates 2 sentences from that information to more of a summarized information for the information. Now if I scroll down, you will see there is a something called previous 3 result. It is nothing but we are storing all the information which was asked previously into a database, SQL database, and retrieving information from there. So I'll quickly switch back to the architecture. So this is where I'm talking about when the queries runs, all the informations are captured and stored in this SQL database. So the customer user query, internet search, insights generated from the node, summary node, all that stored here, and then we can call it and display to user as needed. So if I switch back here, that's what it is happening here. And if I scroll down further, you will see there are 2 flow charts are there. So first graph is basically telling how this particular application is designed in terms of the structure. So when somebody starts, it goes to the router, and then it goes to max one different LLM versus Lava 7 LLM, and uses web and gives us the final summary and ends the query. So this is the structure, and on the right hand side with color greens, it tells you what path it took. So for this particular example, or which was not a, I will say not a specific to the mathematical question, it took the route of analyze or web part. Now if we ask anything related to mathematics, it it should technically take mathematical route. So 45, I'll just add 45 plus 55. I know it's a very simple thing. Just for the demo purpose, we'll ask this question. So expectation here is when this max question related comes, the router node, which is Lava 7b, will say that this is related to max. It will pass it to the Quan 2 LLM and provides the output, put it into, send it to the next node, which is finally is going to summarize it, store it in the database, and give it back to the user the information in the front end. So if I switch back again to the demo port, the actual application, so it has completed the execution. The left hand side web search is blank. Definitely it did not went to that DuckDuckGo. It went to Quant2 LLM because it was related to max question. It given us little insight of it, and the results also here. And finally it gave us the summary out of it. telling inside 1 and 2, and it's trying to join the information and provide us the result to us. Okay, now I know it's look weird like inside 1 and inside 2, but this is how Lava 2 has decided to combine that sentence and provide us. So we can change the prompt of Lava 2, make it more crystal clear so that it doesn't give like inside 1, inside 2. Those control, we have it, and I'll show you how can we do that. So now if I go down, you will see it is capturing the last record, and that it is moving the previous record to the second last record, and so on. And if I scroll down back to this execution path graph, now we see this green color is for showing it took the max route, and it is changing the color accordingly. So this graph is dynamically created as per the user is asking question, and we can make it more complex as we need, in as per our need we can modify it. So that's not a big challenge, I will say, for now. So I'll switch back to this entire architecture view, uh, where you can see this is what the execution happened here on the max side and provided the answer. Now I think that's pretty much cover the right part of it, which is the research and assistant portion of the application. The other section is the PDF section, where let's say we have some very private information, we do not want to share it to anywhere on internet or any cloud applications, where we do not know if we have a control on that information, whether it will be secured or not. So that information, let's say you have so many PDFs to read through it, and you want to just get a summary or its extract, or in fact I'll say we want to talk naturally to that data and get information. This particular portion of the application helps us there. So what happens when user, so let me go back to the application to show you what it looks like in the front end. So if I go back and go to the PDF rec section, if I click here, you will have something called upload the PDFs. And as soon as, so let me do one thing, I will clear this first so that we can take a new PDF document. And so if I click here, and let me take one PDF, which is this one, New York City. It's a simple for demo purpose. So as soon as I click it, the trigger happens. So what trigger happens, I will show you in this diagram, where as soon as user upload this functions begins. So what it does, it takes the PDF document, uses Olama Nomic embed text model to convert the PDF information into embedding and store it into vector database. So this conversion is essential, reason being, for any LLMs to efficiently retrieve an information, it has to be in a embedding format instead of like a PDF or any other text format. It gives that advantage, or I will say more efficiency plus ability to read it. Otherwise it's Lava 7 cannot be able to read the documents information stored in the PDF format. So that's the reason we need this nomic embed text, which will use this PDF and convert that into embedding and store it in the Chroma vector database. All these things are completely open source code, so we can modify as per our need is needed. And again, your documents remain in your local machine, it doesn't go outside, so your information is secured that way. Now, if I once this is stored here, a user can ask query. It will go to Lava 7b, which is an LLM. It will talk. It will go to this database, retrieve the information, and send it back to query user in the front end. So if I go back here, so this is where it is. It says loaded and indexed for rack. It's basically meaning it's that it has been put into a vector database and index and for rack so that you can ask question to it and look what into it. So what I'm going to do, I'll show you that PDF document, how it look like. So this is how the PDF document look like. It has New York City related to transportation. There are some related to bus, rail, and so on. So what I'm going to do, I'll just do a sample question. So that does this LLM able to find this information from this PDF and send it back to us. So I'll say, can you talk about, let's say, I'll take this portion. Can you talk about intercity bus terminal? Uh, so I'll just ask this specific question, intercity bus terminal. To this LLM. Let's see what happened. Can you talk about intercity bus terminal from this document? And then I'll press enter. Now, when going back to this, as soon we press the enter, I'll go to the application. When we press the enter, it goes to this Lava 7b LLM. This LLM then calls the vector database, try to get the information from it. It doesn't go anywhere, internet or anything. It just goes here, this information, and only this information has been passed to the query. So that's how the function has been built. We will see when we go through the coding part of it. I will know how it is not going outside and anywhere. It's just within this context. So it will take some time because it has to first the Lava 7 will has to read through the document and find the information and send it back to us. So if I go switch back to this application, so you see it is running and it's processing. It will take some time, but I'm more interested how what information Lava 7 is able to do retrieve from the track. So we'll see how it works. Now this is more of a kind of a demo. Just to let you know, I am using 22 core Intel processing, and the RAM I have is 32 GB RAM. So to load this multiple model at the same time, you do the screen recording, so it requires memory and processor. So see, it has thrown out that information, intercity bus terminal, New York City. So that means it was able to get that information what we asked from that document, and it was successfully able to do that. And it's written in more natural language way so that it's easy for us to interpret what is there in the document. And you can do it with more advanced, like let's say you have a research paper, you want to understand, just put it in there and talk to that PDF document in more natural way. And again, it's completely in your local machine. You do not have to worry about how many tokens got used and is it going to expire and all that thing. And also it's not going outside, it's completely in your local machines. That's the advantage of this particular application. So if I switch back to the things, everything I think I've covered from this architecture view. Just requirement is 16 GB RAM. That's what I was talking about. I think more is better, of course, but it's become more expensive as we go up. Okay, all right. That's pretty much from the demo as well as application architecture. We will go to the next part of the video. Thank you so much. In this section, I will like to cover the how we can install this application which we discussed in the previous recording locally. Okay, so what we're going to do is the first thing we need is Python. I'm hoping Python is there in your installed in your system. If not, you can follow these steps to get Python installed. Then second thing, we'll need Git. Git is basically help you to download the application which I'm storing in GitHub directly into your system. All the required files can be pulled it in one go instead of figuring out which files to be download and how. Now once you do this step, this is the basic steps you have to do it. The more important part I want to cover is getting the Olama, because that's what we will need to make this application run, because behind the scene we are actually orchestrating different kind of LLMs stored running completely in your local machine. So these are the steps basically you need to do it. I don't want to go into details of this. I think this is very self-explanatory, click and follow kind of actions you have to do. So once that Olama is installed, the more important part I want to cover is these three LLMs. You need to follow this command from your command prompt and pull LLMs once the Olama is installed. So these are the things, you just copy it in your command prompt and send it. It will download from that. So that it may takes time. So that's why I'm saying just don't worry about it, because depending upon your internet speed, it will take time, because its size is big, 8 GB and so on. Now once it is downloaded, if I scroll down, all you have to do is provide the GitHub command from your command prompt. It will go to my GitHub library and pull the required files into your local system. Then all you have to do is do this pip installation. So what all libraries you needed to run this application will be installed in one go. So that's why it's recommended to use this command. Finally, if you have done that portion, all you have to run is trigger the Python command to launch the application by simply putting this command and click on this icon, which is basically your local browser at 7860. This application will launch, and then you can play around with it, read through the codes and everything. That should do it. There are certain things which I've just mentioned is 16 GB at least, I know, because the size of the LLM. If you have GPU, awesome, but if you don't, still it will work, because I'm not using GPU, but still it's working in my system, so it should work. And if anything else, definitely feel free to drop questions around. I'll try to help as I get time to solve your queries. This is all about how to install locally. The other aspect of is we will go to the code, which once you have this local multi LLM installed in your system, you can go through the code and modify it as per your need. So I'll give you a quick rundown of this code, and I'll show you the more important code where you can modify so that you can do it the way you want to do it for your future applications. So the first and basic part of this code is, if I click expand this, you are bringing all the required libraries, importing that libraries from here. So as you see, this is I'm using LangGraph more primarily, the important thing, which is helping to design, orchestrate your LLM as per the customer. And again, good thing about LangGraph is open source. You can see the entire code and modify as per your need. Hence, I'm using that one. This is more. I can quickly go through it. So the other thing is what you need is SQLite database to store information from the message user put, as well as LLM generated informations are stored here so that we can retrieve if needed. Gradio is for your front end where you can modify easily, and most of the MLs AI engineers use this for quick demo purpose and prototyping your applications. Very easy to use it. Then you have Python loader, again coming from LangChain. They have very nice way to put it out and use your open source Chroma database where we can store embedded information. Again, this is Olama embedding is used to talk to nomic embed text, and from the PDF it converts it. So this is how these libraries are used. If the entire this code, I have given the instructions and information and the comments to understand what each of the things are doing. So if, for example, if I expand this class, which is the very important class where the whole things are working, so you will see I have given some basic instruction about what this functions is doing. You get the idea of it. Now, the more important aspect of which I think most of us want to know is, if I go back to this chart, how these nodes are created and how it has been connected. Because in future, I believe you want to add more LLMs, you want to have a different path and tools to build your application. This is where you want to know how to modify that. So I'll go to that portion of the code which is here at the down section. Let me go scroll down. So this is where the main part of it, and the graph, which graph is created. So it's a function, and it is taking it is inheriting the class from state graph. This state graph is built by LangChain and LangGraph team. From there, we are retrieving the basic graph structure. Now it is stored in called graph. You can rename whatever you want to, but to avoid confusion, it's better to keep that naming graph to help you out. Now, first it is this object has been created. Now what happens, you can add nodes and edges to the graph as per your need. Nodes are, you can say, independent. You can think about a circle, okay, where it's an individual item where when it's called, it will do something and throw out something. Okay, that's the node. Edge is a line. You can think about, it's a directional line where it tells you from where to where go. So you can see for this example, this edge, it says from max it will go to final summary, then it shows analyze to final summary to end. It's like a directional arrow which creates how you want to do it. And there should be, for this graph, there should be an end, and there should be always a starting point. So if I show you the graph in our app, so if I go here, down here, so this is what there should be always an end, there should be always a starting point, and there should be a directionals. So this is the node, this is the directional edges. It tells you from this to this you have to go, from this to this. So when you are designing any graph, you have to ensure your graph is, doesn't have like an open arrow, doesn't goes to somewhere and doesn't come back to. So it's like a broken graph. It has to be some logic. Of course, you can do a lot of things, but it has to have some path to start, begin, and end. So that is very critical in designing the chart. You can definitely do way you want to do it. It's customizable. You can create crazy, graph. So back to this. This is why the entry point is critical, where it says where you're going to enter. Uh, the starting point is the router. So the router node will be called, and once it has been called, then you can see there is something called conditional edges. So as soon as this router is called, it goes to this conditional edge. Okay, so if I switch back to this one, this is, it has two arrows, right? It's giving you conditional output, where you see here it's 1 to 1 out, but here this is like two output can be possible. It can have like 3 4 also, you can customize it, but I don't want to complicate thing for now. Just for simplicity, there is two output can be done. So the router, it will decide, okay, you are giving me this information, there is two path to take. One is call max or call analyze. So that's the max node will be called or analyze node will be called. So here if I go back, okay, calling this and this. So that's why. So it enters from here and go to this conditional edge, which is router. Here you can see this router and this router. Okay, then from this it throws out two routes based on the information it gets from the state, and move to the next. So let's say it moved to the max. So you see this edge, it's called max will go to final summary. If I come to max will go to final summary, that's how the code is written. Analyze will go to final summary. So analyze will go to final summary, and final summary will end. Final summary will end. And as soon as it ends, the execution is stopped. The output, whatever the state information is stored, that can be retrieved. It's like the process is completed. Now each of this node you can modify, define as per your need. I don't want to show each of the node. I'll just quickly show one of the max node on the top. It's an LLM. You can modify as per your need. So I want to just quickly show that. Let's go to the max node. So here you can see this is invoking max LLM. I'll go back and you see this prompt: solve and analyze mathematical problem. This is the prompt. You can customize it as per your. You can write literally, I think, anything in this prompt. If it has this LLM has been well trained for that kind of prompt, it will perform well. So that's the ability we get, and the control we get, which I was talking about. How you can control your LLM's behaviors and everything from the code itself. It's here. And how you can control the path of the LLMs. It's here. It's all these things are here. You can manage it as per your need. You change it, it behaves everything differently as per your need. Now that's what I was talking about. You can modify this. It will call this max.invoke. This is where the LLM has been called. Now you want to know where is this LLM, which LLM you're talking about. If you go to the top about here, it is where the LLM is been called. So for example, max is nothing but 1 to LLM. I have rewritten it. You can write it differently. So it has been called, which is the URL where this LLM is functioning or running, is OLM base URL. If I go up, I'll show you that one also. So this is where OLAMA is running in your localhost with the port number 11434. Okay, so all these things are there, and this is where state is stored, basically a base model where whenever the query is run, this get refreshed, this particular state get refreshed, and new information is stored, and based on the state, the graph behaves and takes the path. Okay, so all these things are there in this. You can go through it, but I think I want to cover the main part of it, which I think I covered it. Again, you may have some question. Feel free to drop it in the comment. As I get a time, I'll try to respond. Thank you so much. That's it from MJ here. Hope you enjoyed it. Have a nice future ahead with AI. Thank you. Bye.